Hi, today we are looking at electric fields. So for electric fields, our symbol on our formula sheet is E, and by definition, it is a force per unit charge. Now, if it's force per unit charge, that'd be newtons per coulomb. Now, formula for this, we have electric field is equal to force electrostatic divided by the charge on our test object. Now, the direction of an electric field is defined as a direction that a positive charge will be moved by the field. Therefore, fields will move away from positively charged objects and towards negatively charged objects. For example, find the magnitude of electric field strength if a 3 microcoulomb test charge experiences an electric force of 6 times 10 to the negative 2 newtons. So we've got our charge of 3 times 10 to the negative 6 coulombs. We have a force of 6 times 10 to the negative 2 newtons. We're looking for E. We'll substitute these directly into our formula, and we end up with an electric field strength of 2 times 10 to the 4 newtons per coulomb. Next example, we have find the magnitude of electric field strength 65 centimeters from a 6 microcoulomb charge. So our charge is 6 times 10 to the negative 6 coulombs. Our R value, we want to convert that from centimeters to meters. And we'll once again use E equals FE over Q. Now our force electrostatic, we weren't given, but we have a formula for force electrostatic, which is KQ1 Q2 over R squared. Now, essentially in this case, we're taking Q to be Q1. So we can replace that, and you'll see that we essentially have lowercase q divided by lowercase q, so those cancel out. So we have electric field strength will be KQ2 over R squared. Substituting our values in, we end up with 1.28 times 10 to the 5 newtons per coulomb. Next example, what is electric field strength at point P? So in this case, we've got two charges that are each going to create their own field, and we'll have to see how they interact at that location. So we have E is equal to FE over Q. Now, like we just looked at the previous page, that can gradually be rewritten and rearranged to get E is equal to KQ2 over R squared. Now, we know QA is 4 times 10 to the negative 6 coulombs, because we're going to find the electric field from A first, then we'll solve for it from B and then combine the two. So our distance to P would be for 3 meters plus 1 meter, so 4 meters. So electric field due to A at P would be calculated to be 2,250 newtons per coulomb. Next, we'll get the electric field from B. So we know QB is negative 1 times 10 to the negative 6. Our R is just going to be 1. Substituting our values into our equation, we get negative 9,000 newtons per coulomb. Now, adding them together, we end up with negative 6,800 newtons per coulomb.